Now, welcome back, ladies and gentlemen, now that I have everybody's attention. So I'm looking at sine, cosine, and tangent ratios. This is a continuation of what we were talking about yesterday. Cohort A is at home, and cohort B is our studio audience. So, sine, cosine, and tangent ratios. First of all, they only deal with a right triangle. Here's a right triangle. The first thing we do with any right triangle is we circle the 90 and we show where the hypotenuse is. Now, in class yesterday, I made a big deal about that. I'm looking at the studio audience. Do it. Circle and show where the hypotenuse is. Next, figure out which angle we're working with. We're working with angle A. So that means that this will be the side opposite A. So that is the side that's opposite the angle A, and this is the side that's adjacent to angle A. You need to be able to figure that out, and it needs to come naturally. So, what are the ratios? Now, you should have this memorized by now, and if you don't, then you better do it very, very quickly. May I suggest getting a tattoo, perhaps, if you need to. But you need to memorize that the sine of angle A is equal to the opposite side divided by the hypotenuse side. And remember that those are side lengths. And this gives us what's called a ratio. Cosine. Cosine is adjacent side length divided by the hypotenuse side lengths. And finally, tangent. Now, we didn't talk a lot about tangent yesterday. I introduced it, but we didn't do any questions with it. Tangent is opposite over adjacent. So there's no hypotenuse involved in this one. Something that's very important that I want you to realize, all of these are side length ratios. And remember what a ratio is. A ratio is when you take one value and divide it by another. And often these will be represented as fractions or decimals. It can be represented in both forms. And all of this is contingent on this angle A. So, here's some examples. Solve for x in each of the following. So, A, B, and C. We want to round our final answers to 2 decimal places. Okay, so we have all of the instructions. This is what you do, and if you're not doing this, you're going to get it wrong. You need to circle your 90. You need to then locate your hypotenuse. Then locate which angle you might be working with. Angle 40. From 40, this is my opposite side. From 40, this is my adjacent side. Now, take a break. Think for a minute. What have I been given and what do I want? I've been given my hypotenuse. I've been given an angle. And I want my adjacent. You need to stop and do these steps. The number of times kids look at me and say, okay, what trig do I use? And I look at them and say, well, you have to decide based on the question. This is what you have to do. So you need to look at this and say, I have adjacent, I have opposite, I have an angle. Which trig ratio, this is the question, which trig ratio works with adjacent and hypotenuse? Studio audience? Studio audience? Cosine. Very good. The cosine of any angle is equal to adjacent over hypotenuse. You need to know that. If you don't have that memorized, then I guess you're going to do something like this. So, ka, toa, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now I'm looking out over my studio audience with glaring eyes because only one of them was able to give me the answer and the rest of them look like frightened deers caught in headlights. No, children. You were at home for a full day. You were supposed to have learned these. I expect these learned. If you don't know them by the end of today, You're behind. We're in serious trouble. All right, so cosine, adjacent over hypotenuse. I'm going to put in the numbers that I have. So instead of an angle, theta, I actually have a number, 40. Instead of adjacent, I have an unknown, x. And instead of hypotenuse, I have a length of 130 centimeters. Now it's just math, okay? Trigonometry is out the window. It's just math. Let's look at this for a minute. This is simply a decimal. Cos of 40 is a decimal number. This is a number, and this is an unknown. I want to solve for x. In other words, I want to isolate x. I want to get x all by itself. How am I going to do that? Well, what is the 130 doing to the x? It's dividing by x. So if I was to multiply 130 on this side, it would get rid of the division of 130. Would you agree? It's the opposite operation. So if I multiply this side by 130, I get rid of the division by 130. Well, that's cool. Which leaves me with just x. But if I'm going to multiply this side by 130, to keep the equality, I have to do the same thing to the other side. So I have to multiply the cos 40 by 130. Now, does that make sense to everyone? Now, I'm going to write something that you don't have to write, but I want you to see it at least once. What I did was I multiplied this side by 130. That's what the dot means. And I multiplied this side by 130. So really what I did was I multiplied both sides by 130. And what happens is this 130 reduces with that 130, leaving me with x equals 130 cos 40. Now this is algebra. And we have to learn our algebra. And chances are most of us have a hard time with algebra. So I want you to see what's happening. Okay? So now, I'm left with this. I grab my calculator. I make sure it's in degrees. If it's not in degrees, all your answers will be wrong. I do, depends the order that you want to do it in, depends your calculator. I'm going to do 40 cosine, which is this decimal. And then I'm going to multiply that by 130, and I'm going to get 99.59, rounded to 2 decimals. The actual answer was 99.585777761, and it keeps going. Notice I said that it's approximate because it keeps going, but the question said to round to 2 decimal places. What that means is I want to keep 2 decimal places. So I want to keep 2 numbers after the decimal. So I look at the third one. It's 5. That means it rounds the 8 up, and our approximate answer is going to be 99.59. And the units will be centimeters because that's what I was dealing with, centimeters in the question. Let me open that up a little bit so that we can see the whole thing. And that is how you do a question like that. Any questions from the studio audience? No? You're going to be expected to do this on your own in just a minute. Okay? I'm going to put a line down here. So I separate what I'm doing in the two of them. And I better put a line down here so I don't run out of room for the last one. Okay, next one. No word of a lie, kids. No word of a lie. Start like this. 90, height. Angle, opposite. Adjacent. No word of a lie. Always start that way. Then stop. Then say to yourself, what am I given? Well, I'm given an angle, I'm given a hypotenuse, and I'm given an opposite. I wasn't given anything about the adjacent. That is the adjacent, but I don't know anything about it, right? It's not an unknown, it's not a number, it's just the adjacent. So the question is, which trig ratio am I going to use that uses opposite and hypotenuse? Studio audience, someone other than my last participant. So studio audience, I need a trig ratio that uses opposite and hypotenuse. By me? Sine, not he said sin. Boo, boo, hiss, hiss. He said sin. Sin happens in religion class, son. It's sine in math class. So it's sine of 58 degrees, so I'm going to put in the number, equals opposite x over 70. Look at that. So that's worth 2 marks. So now, what I want to do is isolate for the x. I want to get the x by itself. So the question is, how do I do that? Well, look at the 70. The 70 is dividing the x. So what's the opposite of division by 70? Multiplication. So we're going to multiply both sides by 70, right? So if I multiply both sides by 70, I'm going to get sine 58 times 70. And what happened to this 70 over here was that it reduced with the one on the bottom, and that's why we did it. The whole purpose was to get rid of that 70 on the bottom. So now using my calculator, 58 sine times 70, and we get an answer of x equals approximately 59.36 meters. Notice I skipped this step. If those of you want to put it in, please do. But this is certainly what you should be thinking in your head.
I do 50 times sine or whatever.
When you do 50 times sine,
50, yeah.
you should be doing 58 sine.
Yeah, it just does that on calculator.
Well, because your calculator, I think you have to hit sine first.
Oh, okay.
So hit sine first,
Yeah. Okay.
then hit 58, hit equals,
Yeah.
then times 70. So, yep, each calculator is different, and you need to learn how to use yours. Last one. Let's see what I got. 90. Height. The angle. Opposite. Adjacent. What am I given? Angle. Opposite. Adjacent. I need a trig ratio that works with opposite and adjacent. Someone who hasn't answered me yet from the studio audience. Who's it going to be? Yes? 10. The man's on a streak. So it's going to be tan 25 equals opposite over adjacent. So, now what we want to do is isolate that x. So what we're going to do is we're going to multiply both sides by 13. Using your calculator. I get an answer of approximately 6.06 millimeters. What do we think, kids? Okay, those of you at home, on the other side, there are questions. 1, 2, 3, 4, 5, 6. I want you to work on those questions, and we will be back with the next lesson in just a few minutes.